Welcome to a lesson with Dr. Powell. Let's rotate a conic section. Let's take an ellipse. X squared over 4 plus y squared over 16 is equal to 1. And this ellipse will be 4 from the center, going up and down, and 2 going right and left from the center, which is just at the origin. And let's rotate it by pi thirds counterclockwise. So that'll look like a plus. Okay, now the schematic for how this is going to work is a point in the plane, x comma y, that we want to appear on this graph, which is pi thirds rotated of this. If we were to go backwards pi thirds, we should land on this graph, or which means it should be a solution to this. So however this rotates down to an ordered pair, whatever's here and whatever's here we should be able to plug freely in to x and y, and this equation still be satisfied, which means it's on this graph. So what we're going to do is we're going to take the point x comma y, and we are going to rotate this point by pi thirds clockwise, and then plug in the result into this equation and into the x and the y, and the solutions of that equation will actually represent the conic rotated pi thirds. So we need to figure out how to do this part, and then we're essentially done. We take x, y, and we rotate it pi thirds clockwise to get an ordered pair here. Well, if we think about this in terms of vectors, we can use the notation with this type of angled bracket to represent a vector, which is nothing more than from the origin, an arrow coming from the origin to that point, and it has direction and it has length, so we can call it a vector. You can add vectors in various ways. We could have a vector going this way and this way, x0 and 0y. So these two arrows actually add. How do they add? You take this arrow right here, pick it up, take its tail and put it on the tip of this other one, and it takes you to the destination. And then the final resulting path from first tail to final tip is the result. So really we can represent this x comma y as a vector being a sum of the two components 0y and x0. Okay, so to rotate this picture by the amount that we want to involves simply rotating these components in the clockwise direction pi thirds. Now this vector right here is actually a rescaling, so a y value times 0, 1. This simply means that y hops in and multiplies to each respective component. And similarly, this is just x times 1, 0. So really what we're going to do is we just rotate 1, 0 and 0, 1 clockwise by pi thirds. Now these are on the unit circle, so rotating should be pretty simple. This one rotated by pi thirds clockwise will be a cosine sine, and I'll write that in a column. Cosine negative pi thirds sine negative pi thirds. That'll be the final destination of 1, 0. What's the final destination of 0, 1? Well, basically it's the same as this destination, but it's pi halves counterclockwise added to it. So it's because this is pi halves counterclockwise added this way, so when it's rotated, the same thing will the same idea will be preserved. So the destination of 0, 1 will be on the unit circle, negative, or would be cosine of negative pi thirds plus pi halves, and sine of negative pi thirds plus pi halves. Okay, so let's see how this is going to work. If we take, if we take cosine of negative pi thirds and sine of negative pi thirds, remembering what this is, and the other one, plus pi halves, and sine of negative pi thirds plus pi halves. Okay, so this is the destination of 1, 0. This is the destination of 0, 1. Now, we could, in some sense, notice how we wrote these in columns. A few different ways to think about it. We could take a matrix multiplication of this and xy and end up getting as a result, I'll put it down here, x cosine negative pi thirds plus y cosine negative pi thirds plus pi halves. We could get x sine of negative pi thirds plus y sine negative pi thirds plus pi halves. Now this top part is actually going to be what we plug into our coordinate, the x place of our coordinate that we were after, and this is what we plug in for y. And kind of think about what's happening here. Basically what we're doing is we take the destination of 1, 0, which is this, multiply it by x. So if we multiply it by x, notice how the x distributes into this part as just being x and x. Similarly, so this is x times that, y times this will carry into the destination. It's just rotated, the vector, so it's the rescaling is rotated. You just get a y and a y. And then you simply, and then just as vectors add here across in the initially, they do in the destination as well. So because rotation preserves the addition, so you just add across. So this is actually going to be, so this actually replaces what x was, and this actually replaces what y was. Notice that the same idea is actually detailed in this matrix multiplication as well. So remember that we were starting with the equation x squared over 4 plus y squared over 16 is equal to 1. So all we really need to do is replace this x with this, and we can compute with this right here, and we can compute what this is. Just successfully rotated our shape, rotated our graph.